So this is one of the interesting questions from GATE 2026 Mechanical Engineering, where some of you have sent me the messages and queries about whether they should challenge this question or not. So let us have a look at this question. Let us have a look at the wrong approach of solving, then the right approach of solving, and then whether you should challenge it or not, and some very interesting learning. So even those of you who are quite clear in this question, if you don't have any confusion, if you don't want to challenge, still I would encourage you to watch this video, because there will be some useful learnings that I will be giving you, which will be helpful for you, not just for GATE but for many other exams. So this is the question. Diagram has been given and the question says a workpiece is to be firmly held in a fixture. You can see workpiece is mentioned here. This is the workpiece, right? And this workpiece is firmly held in a fixture. You can see fixture written here, and these are like clamp holding it. That's what fixtures do, right? As we know, fixtures fix the position of the workpiece. They keep it held at a specific position. It is to be machined by using a plain slab milling cutter as shown in the figure below or figure aside, because I have taken the direct, this image is directly taken from the official paper, hence I have placed it on one side. So as you can see that it is being machined using a plain slab milling cutter. You can see this is the milling cutter. This is how it is rotating. This is how the blades are, its cutting edges are, right? And this is like doing, it is doing up milling. You can see by the direction of rotation, it is doing up milling, right? Conventional milling or up milling. Now, which one of the following options is the most suitable value of height h of the fixture in mm? So as you can see in this diagram, this is where h is written, right? This is the height h of the fixture. This is the height h of the fixture, okay? And it is asking you what is going to be, read the question language, it's quite interesting. It is not asking you the exact value. It is not saying what will be the exact value or what will be the value. It is using a very ambiguous type of word. Which is the most suitable values? Because there can be more than one suitable values. That's what it is trying to imply, that there can be more than one suitable value, but you tell the most suitable. So that's an interesting question, I will say. And such questions make sense in MCQ, right? You will soon realize why. So 200, 210, 150, and 70, all in mm. This is the question is. Now, the wrong approach that some of the students are trying to use here, and I have seen even the solution, some of the institutes are doing it incorrectly, is what they are doing. They are treating this workpiece like a column, because they can see the workpiece is standing vertical, so they are treating it like a column. Please note that you treat it like a column and then you try to find out effective length. All these things you can do only when you look at how this workpiece is being loaded. Please note, if there is a vertical looking workpiece and maybe it is held like this, then it does not mean it becomes a column and you will start applying effective length formulae to find out whatever you want to find out. That's not the right approach. You have to look at the load, the direction of load. For such questions, if you want to treat them like column, the load has to act axially and it has to be a compressive load. Then you can go ahead and whatever analysis you want to do, you can do. Is this the case here? Absolutely not. So those students, they are missing one key observation in this question, one key data that is given in the diagram. Notice this, feed and the direction of feed. They have given you that it is being fed in the horizontal direction, but what they are doing, they are not paying attention to this word. They are just looking at this and they are maybe assuming, I don't know, they are thinking that it is going to go in the downward direction. There is nothing in this question that suggests that, nothing at all. The direction of feed tells you that the motion is going to be horizontal, and not just this, even the diagram suggests you that, right? If you look at the diagram, this is the surface which is getting machined, right? This is the finished surface. This is the finished surface and this is the unfinished surface. So you can clearly see that this is moving in this direction relative to the workpiece. It's not necessary that this has to move, workpiece can move as well. The fixture is going to move it, but relative motion between them is going to be along this direction. Only then it is possible that you have this as the finished surface and this as the unfinished surface. If it was going in the downward direction, this part, how it can be machined? It has not even touched the cutter so far, right? Now, coming to forces. The cutting forces primarily will be in the cutting direction, right? Obviously, the direction in which it is going to move, the feed is being given or the relative feed is being given, that is the primary direction of cutting. So primary forces are going to be in that direction only, right? We already know how forces act in such cases. But there will be some vertical force as well. I am not saying vertical force will be absolutely zero. Some component of force is going to be there, because purely horizontal force is not going to be there. You can see it is cutting at this point only, at this point only. It's not a point load or a point force. It's a distributed force, right? Cutting is not happening at a single point. It is happening here as well, here as well, here as well. At different points it is there. Resultant will be primarily horizontal, but some component of force will be vertically aligned as well. But that also will not be compressive. That also will be in the upward direction. The resultant force will have an upward component, and you can also understand that from upmilling. This is upmilling, right? This is upmilling. So basically this is digging into the workpiece and lifting the chips up. It is lifting, it is digging in the downward direction and it is lifting them up. It is trying to tear them, right? So it's trying to pull them up. So force the workpiece is going to experience a small quantity, a small amount of vertical force, that also will not be compressive, it will be tensile. Hence, you absolutely cannot apply any formula or concept of columns. That is absolutely wrong conceptually. So, this was, firstly I wanted to address what is the wrong approach that many of the students are trying to apply here. Now coming to the right approach. So what exactly is happening here? Look, this is such an interesting question. As I told you, it is asking you to pick most suitable option. So you have to analyze each and every option, and based upon that you have to decide which of the option is most suitable. Now it is such a question where no force is given to you, right? Some of you may try to think, even I was trying to think that maybe some force will be there when this question first came in the memory based. So most of the times in memory based questions, the data here and there are missing, right? Single words here and there are missing. Like this direction was absolutely missing. This was not provided in the memory based question. So I was also not sure what exactly is going on here. I was also not sure whether this is like this or this is like this, or whether this diameter is entirely capturing what is going on, right? But when I saw this question, when this entire question was available, then certain things becomes clear. What? That firstly, you have to do whatever you have to do with these two values only, because those are the only two values given to you. No force data, nothing given. Even its diameter is not given to you. You can see it is smaller than that, but nothing more than that. So these are the only two values which are given to you, right? So now you start thinking, what can you do with that? Here you can see, as I was discussing about force here, and it's a question of fixture. It's a question of fixture. The role of fixture, what is the role of fixture? It is to hold the workpiece firmly, right, in the required place, in the required position, so that there are minimum distortions, minimum shatter, minimum vibrations, minimum unwanted movements. That's the role of fixture, right? And here, if you notice, since primarily this is the direction of force, feed force, this is, or cutting force in this case, that it is going to experience, because feed is in this direction. Basically, cutter is at the same place, rotating, and this whole setup is moving to the right. But relative motion, we can take that relative motion is going to be like this, right? Or force is going to be felt in this direction. So if you look at that, it is trying to bend it like this, right? Let me clear it up. The force which is acting, which will be acting in this direction, in this direction, it is trying to bend it like this, right? I am exaggerating. This much will not be the deflection. I am exaggerating. I am magnifying it so that you can feel it better. So this is how the force is trying to deflect it, right? To give you a better feel of what I am saying, let me first show you this diagram. This is the same diagram. This is just, it is drawn by me, hand drawn, but same diagram which was given here, right? So if I take this diagram and if I rotate it 90 degree like this, 90 degree clockwise, if I rotate, then this is what I am going to get, correct? Same diagram, 90 degree rotation, this is what I am going to get, correct? Notice, same force direction. Here it was like this, here it is going to be like this. I have just rotated everything including the force direction, right? So here, this is how it is acting. And now you observe, same thing what I told you there, that this is how the force is trying to bend it or trying to deflect it. And we want to minimize that. We want, as I told you, the role of fixture, these are the fixtures. The role of fixture is to minimize unnecessarily deformation and deflections and shatter and vibration and movements so that cutting can be done accurately, precisely, right? Because if it deflects from its position, whatever input was there, it will not match with the output. And hence your cutting, your final measurements won't be accurate. These are the basic things that we know about fixtures and their role in machining. So here you want to minimize that. You want to minimize this deflection. Now how do you minimize that? Force is acting, but deflection needs to be minimized. So there is one formula which you can use here. If you look at this setup and try to intuitively feel what is going on, it is acting like a cantilever beam. So it is not a concept of column at all, it is a concept of beam. Both are absolutely different. In column, the force has to act along the length, and that too in a compressive direction. In beam, primarily forces act perpendicular to the beam. And that is what is happening here. This workpiece is like a beam and force is acting in this direction. So you see how the concept of production, manufacturing and production is combined, is linked with the concept of strength of materials to get you the answer, the desired answer. And if I write the expression for deflection at the free end in a cantilever beam, so this is the expression that we all know. E, I, P, these are not the relevant values for us. The relevant value is this L. What length we have to take? Do we have to take this length or this length? What was L here? Recall, L was the length of the beam which was unsupported. If there was a cantilever beam, and it was embedded like this, so length was this, the part which was out of the fixed support, which was unsupported, the part which is fixed and held and clamped, that part which is not able to deflect, that is not the part of unsupported beam, that is totally supported, that is actually part of support. Only the part which is beyond the support, beyond the fixed wall, beyond the clamp, that is where deflection and deformation is possible. So L here, the effective length here is this much, this much, this much. The part which is free to bend, free to deflect, that is the effective length here and not the entire thing. This is another point where you have to be careful. And now, since you have understood this, now let us come back to the question. Question is asking you which of the following options is the most suitable value of height h of the fixture in mm. So it is not asking you this, it is asking you this h. So this is L, pay attention, let me again bring you back here. This is L, this is L, this is h. It is asking which will be the suitable value of h. You need to minimize the deflection. You minimize deflection means L should be minimized, length should be minimized. So you want to keep L as small as possible, which means h value should be as high as possible. So does it mean 210 is correct? No, wait a minute. This is why I am saying whenever you have such questions, especially in MCQ, in such question where it is asking you most suitable, you check other values as well. To decide what is most suitable, you need to look at all the other options and analyze whether that is fitting or not. So here, if I look at this option, which looks like correct, 210, highest value of H, which we need for smallest value of L, for smallest deflection, because in fixture we need smallest deflection. But 210, it's not feasible because this length itself is 205. Up to this point, it is 205. So how is cutting possible if fixture is even bigger than the workpiece? If here in this case, if I show you this up to this point it is 205 and fixture needs to be at 210. So how does that work? How does the cutter is going to cut? How this is going to move if fixture is in the way? If the fixture is higher than the workpiece, how the cutting is going to happen? It's not going to be accessible for even the cutter. So workpiece needs to be higher than the fixture. Fixture's role is not to hide the workpiece. It is to project the workpiece but still keep it firm, keep it held, right? So the first, this option 210, highest one, is actually not feasible from the cutting point of view because cutter will not be able to access the workpiece freely. So the next possible is 200. If you look at 200, again, I'll take you back to this diagram. So in this diagram, if this H is 200, it will be lesser than 205, which is fine, right? So since this is gone, the next best option, this was not feasible, so next best option is 200, and that is the most suitable. 150 possible, but there will be more deflection. As I told you, deflection is proportional to L cube, right? So as L value is going to increase or as H value is going to decrease, means from 200 to 150, the deflection is going to increase a lot, right? Hence, we are going to stick with this value, which means the minimum value of L is possible when the value of H is very close to 205, but less than 205. So 200 is the most accurate, most suitable answer for this question. So now those of you who were trying to challenge it based on the earlier approach, wrong approach of column, they are doing something not correct approach and they are somehow getting an answer close to 150. So whatever concepts you are applying to reach closer to 150, that concept itself is incorrect, hence 150 answer also is incorrect. Now coming to what I was, so don't challenge this question. First of all, if you want, you can just go ahead and challenge this question, but I don't think that this question's answer is going to change in the revised answer key. Now if you look at this question, what I want to tell you, irrespective of whether you want to challenge or not, or whatever you want to do with this question, that in such questions, whenever you get such questions in GATE, and if you are not sure of the answer, like in this question, this is a question, you can say it's a question based upon combination of manufacturing and strength of materials, or I will say this also can be considered like a technical aptitude question, right? Not perfectly aptitude question, but a question where you don't have to know any specific formula. Even the formula that I showed you, PL cube by 3EI, you don't have to know that as such. Yes, you know that if L will be more, length will be more, deflection is going to be more. That's a very basic concept that we cover in strength of materials. And a common sense, it's something which is a common sense, right? So in such questions where you are not sure what formula will I apply, question looks very vague, only two values 100 and 205 are given, question also, language is also very vague, most suitable value, on what basis? No basis is given. So question definitely looks vague. I am not saying that everyone should have solved this question and this was so easy question. In exam hall, it may not strike you because the question language and representation is slightly vague. So in such cases, never ever select an option if you are not sure. You may get the correct answer, right? There can be some of you who might have just thought of some random concept and somehow they would have landed up on 200 and they would have ticked 200 and they would have got the answer. But there are equal number of such aspirants, I am sure, who have done some random calculation, they were unsure and they have ticked some incorrect answers as well. and this is MCQ, you lose your marks, you lose your time, that is there, but you lose your marks, they have negative marking. So whenever you get MCQ questions in GATE and you are not sure about the answer, please do not tick anything randomly, leave the question. That's the best strategy for such question if you are not able to think of the right approach to solving them. All the best.